All right, so it looks like it's 11 o'clock. So we're going to get started in a minute. So I just want to remind everyone to use the Q&A box for any questions. We're going to have a live Q&A after the webinar broadcast. So feel free to use that. And if you have any issues, logistical issues, feel free to use the chat and I will work to address them. But with that, thank you guys for joining us and we'll go ahead and get started.
Welcome to the first in a new 2022 four-part webinar series. I'm Julia Speaker, Project Manager and Casted Team Lead in the American Metal Casting Consortium's Innovative Casting Technology Program. Casted is an acronym for what we do, Casting Advanced Systems Technology Integration Team. Our webinars are funded by the Defense Logistics Agency. For those interested in learning more and those seeking continued education credits, please participate in the 30-minute Q&A session following the instructional portion of the webinar. This new webinar series is a continuation of the theme of our Casted Team 2021 webinars, helping new contract awardees in the production of DLA legacy castings with insights to shorter lead time for first article approval and production launch. The 2021 practical foundation in both Casted webinar series was manufacturing engineering for legacy casting launch success and first article approval success. The 2022 Practical Foundation is the project management that precedes the manufacturing engineering of a legacy casting launch, especially in the context of a cold start new awardee who is a machine shop. In our 2021 series, we coined the term cold start to designate a legacy casting contract for which there is no existing approved casting source. The tooling may be lost or unavailable, and metal casting tooling can be complex and expensive, especially for high specification military castings. And lost or unavailable includes machining fixtures. The original metal casting source spent many months manufacturing engineering its processes to become approved. Now, all of that manufacturing insight is lost. To reconstitute the manufacturing engineering of successful compliance with a complex technical data package has to be reinstituted in fewer months by a new awardee and its manufacturing partners. Generally, machine shops are unfamiliar with the manufacturing engineering of metal casting processes. The concept of a metal caster's project management for a casting launch is even less familiar. We are calling this webinar series a project management walkthrough of the tooling, design, and construction and manufacturing process choices for low-volume legacy castings for either DLA Aviation or DLA Land and Maritime. Since 70% of new awardees for DLA legacy castings are now machine shops, the initial project management choices for such a new awardee are: first, cast versus machine from wrought stock. Second, if cast, is the air set sand molding process is the most time and cost effective for complying with the technical data package? Or three, if cast, is the investment casting process the most time and cost effective? And finally, in either casting mold process case, how to plan for the finishing processes for the as-cast geometry prior to machining to final net shape. This series walks through the project management of each of those four legacy casting launch manufacturing choices. First, among the four webinars is the evaluation of the technical data package from the viewpoint of a machine shop. Is it possible and allowable to machine the required geometry from a block of wrought metal that has similar mechanical properties as the designated casting? Here's a short sequence of a 5-axis CNC machining a piece of an aluminum bar. Compared to setting up as-cast surfaces in a machining fixture, just clamping the bar is very simple. Later in this same video, we will see extensive cavities milled into the same bar once the exterior profile is finished. So, machining the equivalent of a casting from wrought stock is attractive to a machine shop. Is that allowable, is our question in this part 1. It is probable that project management is an unfamiliar concept, especially in the context of launching a machine from wrought stock component or finished machining a casting. But it is a powerful concept. While I introduce our next two webinar contributors, enjoy this time-lapse video of project management executed at the highest level, building a bridge over water. As you will see, nothing arrives too soon, nothing arrives too late. and the early sequences don't make sense until you see how the whole complex puzzle fits together for the fastest, most efficient end result. Leading off our 4-part series and guiding us through part 1 is Keith Sturgill, our casted teammate based at DLA Aviation in Richmond, Virginia. Keith is both a materials engineer and an aeronautical engineer with an extensive background in airframe and aircraft engine components. On our team, Keith knowledgeably assists cold start new awardees find metal casting sources, find existing tooling, and assist in answering technical data package questions. Before introducing Keith, Mike Wynn will briefly summarize what project management is in the context of a cold start launch of a complex DLA legacy metal component. Here's Mike.
The objective of the 2021 and this 2022 4-part webinar series has been and is to help DLA procure more efficiently important replacement parts designed as castings for the U.S. warfighter. Procuring, approving, and producing these legacy cast components is very difficult. Unbelievably, the average lead time for legacy aircraft castings is 800 days. While most land and maritime castings are not as demanding in specification and is difficult to produce, the average lead time for the land and maritime legacy castings is still a significant 266 days. Since the DLA bid window is very short, 8 to 10 working days, the likelihood of thoughtful analysis of a legacy casting technical data package is slim for any bidder. That evaluation is more difficult for a machine shop less familiar with the unique technical data package elements for a casting. Here are prominent considerations that a machine shop cold start new awardee should address immediately upon the award of a legacy casting contract. Immediately after award, study the technical data package as would be prudent for any component, but focus on the requirements that are casting specific, such as the material specification, which for a casting will be different and more complex than for an equivalent wrought metal specification. For example, here are the AMS Section 4 quality assurance provisions for machined from bar stock 6061 aluminum, for machined from forged block 6061 aluminum, which is more extensive because of grain alignment, and the comparable A357 cast aluminum. Section 4 is far more extensive for the cast aluminum. The drawing notes and features defining tooling points or datum targets for setting up the casting against as cast surfaces from which all dimensions are measured. As cast versus machined tolerances. There are typically separate drawings, the casting drawing with entirely as cast features and the machine drawing with as cast features plus features upgraded by machining. Possibly assembled features as well. Casting drawings have casting specific tolerances and important casting related notes. For example, as cast and machine tolerances, which are widely different. Drawing notes regarding as cast surface finish. Drawing notes regarding as cast fillets and radii. Drawing notes regarding maximum draft angle, but watch the offset. Draft is really a tangent. Offsets can easily exceed the linear tolerance maximum. Here, however, the drawing note allows 3-degree maximum draft, and the draft offset can be added to a feature dimension plus tolerance. Notice also that core shift is allowed up to 0.03 inch as additive to the feature dimension plus tolerance. Knowing what these notes say is really important. Drawing notes regarding gate and riser contacts, where they cannot be located and how high their remaining marks are allowable on the casting surface. Once the technical data package is fully studied and understood, the foundational first step is to plan the project from start to finish. As we saw in the time-lapse video of the bridge construction, project management is a very powerful tool. The idea is to conceive all the elements of a new project and plan the timing of the execution of the elements one by one so that everything gets accomplished, none too soon, none too late. Notice that I said a new project. Launching a DLA low-volume legacy casting is not business as usual. In our scenario, a new project is a temporary and unique endeavor. It is to produce a small quantity of legacy castings with a defined beginning, a time-constrained end, and a highly specified set of requirements. Fully developed project management defines all the manufacturing tasks in advance, their requirements, their predecessors, and their place in a timeline. So the point is that producing legacy castings under a contract with DLA is not production as usual, in which the awardee just starts in the usual business context. Instead, it is a new project that needs to be managed with a plan before anything just starts. Finishing this first in the four-part webinar series, Keith Sturgill will address the reality that the awardee is probably a machine shop, and he addresses the logical question: can the required geometry, material properties, and other technical data package requirements be satisfied with a shape fully machined from wrought stock? That is, instead of the specified rough casting as the material starting point for the finished net shape. So now, here's Keith to articulate the considerations of cast versus fully machined.
As Mike mentioned earlier, a logical post-award question a machine shop could ask itself is, since machining is what we do, can we accomplish the component's requirements by machining it complete from wrought stock? Today's multi-axis spindle and multi-axis pallet CNC machine tools often enable complex geometries to be 100% machined from a wrought block of material. That is, from plate, bar stock, or forged block. This would include shapes that previously had been casting. As a complex case in point, here is a fully machined V8 engine block compared to a finished machined V8 engine block casting, both made from aluminum. Since casting tooling and prior manufacturing engineering knowledge is likely lost for these cold starts, 100% machining from wrought stock could possibly eliminate potential problems, not the least of which is to find a metal casting source to produce the casting. The typical machine shop awardee is far less familiar with net shaping a rough casting compared to net shaping a rough block of wrought material. So what are the considerations involved in a request to switch from a cast component with significant specifications to a fully machined equivalent with the same significant specifications? Well, foremost is the requirement for a request for variance. The request for variance process is accomplished using the form DD 1694. The form is submitted to the Defense Contracts Management Agency's contract administrator. It is reviewed by them and then forwarded to the DLA contract administrator. If believed worthy, it will then be forwarded to the engineering authority for the component, who then will evaluate and then accept or reject the request. Since a delivery date has already been established in the contract, the elapsed time to request a variance and get it approved is a project management consideration. The typical required response time from the engineering authority to review and approve or deny a variance request is about 30 days. Additionally, it takes a week prior to that for the cold start awardee to fully understand the technical data package and determine if machining from wrought stock is a possibility. And probably another week for the contract administrators at both DCMA and DLA to evaluate and forward a request for variance, which is believed to be worthy of engineering evaluation. So the combined loss of lead time toward a defined contract delivery date would be probably about 45 days. And this is without any guarantee of engineering authority approval. In the context of the cast component's design and application and service, the engineering authority will investigate some things such as: what is the service classification for weapons system safety? Is this a critical safety item, in other words? Another question they would look at is, what is the load case on the casting? And also, is the proposed wrought alloy sufficiently strong and ductile in both its longitudinal and transverse grain orientations? And the reason for looking at that is they want to consider, will stress corrosion cracking be a concern for the alloy chosen? In some sustained load cases, such as you would see with press-fit bushings, the anisotropic grain structure of a casting might actually be preferable to a stress transverse wrought grain orientation. In other words, the unaligned grain structure of castings in some alloys may resist stress corrosion cracking in service actually better than a similar wrought alloy. Something to be considered. Another very important question is, does the part geometry have interior cavities not amenable or accessible to 5-axis machining? Here's something else, and I've learned this from my personal experience. Thin-walled parts, which are machined from stock, and these are pretty typical and very common among airframe components. I'm talking about when these are machined from wrought stock. They will distort. So after machining, or even during machining steps, thin-walled machined from wrought aluminum or magnesium parts will have to be solution heat treated to soften them prior to straightening. So you need to be aware that these age-hardening alloys, they do stiffen and harden and become almost impossible to straighten just within hours. Because of the magnitude of these residual stresses, machining may actually have to be done in multiple light cut stages, with heat treat softening and straightening between each machine cut. So an important question for a machine shop is this: is there in close proximity a capable solution heat treater to assist in the back and forth softening and straightening process? Machining cuts and castings are less significant. In other words, they remove less volume of material. So typically, the straightening during machining steps, those are not required. So metal casters making thin-walled castings in these alloys, they typically have heat treatment in their finishing facility. And they also have either in-house machining or local machine shop partners. So the process is much easier to accomplish. In summary, here are a few bottom line project management questions that a machine shop should ask itself. Now, these questions assume that a prior approved metal casting source does not exist and casting tooling cannot be found. So first, when considering a request for variance to machine the component from wrought stock, you would want to find out, has a request for variance to machine the shape from an approved wrought alloy equivalent, has one been approved in the past? A second question, would seeking a first-time variance, will that positively or adversely affect the component cost and the contract delivery date? Another very important question, if the geometry is complex and the contract quantity is small, would programming complex multi-axis CNC tool and pallet movements, would that be justified? Probably for small contract quantities, that cost would be justified. However, if the contract quantity is larger and prior buys indicates follow-on orders, well, then finding a metal casting source and investing in new casting tooling will likely be much more cost effective in producing the final machined net shape. And last but not least, if a RFV is sought but denied, can the 45 days or more lost lead time be made up? A machine shop would probably do well to consider, parallel efforts. In other words, seek both at the same time, seek both a request for variance and to seek or look for a capable metal casting source and consider manufacturing new tooling if tooling doesn't exist. Those type things are good project management planning.
The high percentage of machine shop bidders for DLA legacy casting contracts is a logical consequence of the significantly changing demographic of U.S. manufacturing between machine shops and metal casters. In the 1950s, the ratio of machine shops to metal casters was 3 machine shops for every 1 metal caster. Machine shops have been more resistant to the decline in U.S. manufacturing than have metal casters, by a wide margin. By 2022, the ratio, even with some decline in machine shops, became 9 machine shops to every 1 metal caster. Once a machine shop has won a cold start award, it is logical based on a machine shop's multi-axis machine tool capability to want to machine the shape complete rather than procure a casting. Even if the machine shop doesn't realize that an approved metal casting supply chain is almost always broken and the tooling may no longer exist. It has been our purpose in this first webinar in the 4-part series to help machine shops in thinking through process for a successful start to a DLA legacy casting contract. That thinking through process, that is, project management, for a casting startup is probably unfamiliar to a machine shop cold start awardee. It's our hope that fleshing out machine or cast project management has been helpful to machine shops, illustrating that just starting the project as usual is the wrong tool for the task. Hopefully helpful in not falling short at the finish line or missing the boat entirely. It is also our hope that the complexity of cold starts for new awardees has also been enlightening to the DLA contracting and engineering authority folks as well. If the awardee is a machine shop and the manufacturing process remains a casting, parts 2, 3, and 4 of this webinar series address project management thinking for most logical metal casting molding processes and their finishing processes. In our next webinar in this series, our CASA team will address a walkthrough of the air set mold cavity making process. The walkthrough will continue to focus on project management thinking. Air set, including making mold cavity elements from additive manufactured 3D printing of sand, is one of the 2 most logical metal casting processes for DLA cold start legacy castings. We'll announce the date and time of part 2 with an email to you personally. Thank you for joining us today, and remember to participate in the Q&A following this.
All right.
Welcome to the first in a new 2020.
Let's not replay the video. So, good morning, everyone. My name is Julia Speaker, and I'm the Castit team lead. So I want to thank everyone for joining us for our first webinar in the Project Management Approach series. If you've attended our previous webinars, you'll notice we changed the formatting a little, where we're hoping to do a high-level video at the beginning. That way we can really go in depth on any questions that you guys might have as the attendees. We think that'll be the most useful. So before we jump into the Q&A, which feel free to add any questions you have as I'm speaking, I'll just take a minute to introduce the Castit members that are on the line. So we have Mike Gwynn on the line, who you saw in the video. He is a casting design expert. Dick Tiano is on as well, who is an expert in all things 3D data. Keith Sturgill, who you met in the video, is a metallurgical engineer and an expert in all things DLA and government processes. And last but not least on the line, we have Gary Burrow, who is a 5th generation pattern maker and all-around casting guru. So while I wait for some questions to pop up, I have a question for you guys. So one of the benefits of using Zoom is I get to do polls. So I am going to launch a poll, and if you do not know the answer, then please take your best guess. I'm going to ask Mike to go over them at the end. You may have to kind of, depending on your screen size, hover over the answer choices just to be able to see the full choice, but I'll give everyone a minute or so to read through those, and then we'll go ahead and cover it. So while you're reading that, I am gonna let everyone know we have recorded the webinar. We're recording the Q&A as well, and we will be providing a link to share with others as well as if anyone registered or if you came in late and didn't see it, we'll email that out to everyone. All right, so I think we have most of the answers in, so I'm going to go ahead and end that poll. And it looks like the majority of people got it right. So Mike, if you want to maybe talk a little bit to that first answer. So the question was, project management in manufacturing is?
Yes, the main point is that even though you may be producing similar parts in your portfolio as a machine shop or as a metal caster, being partnered with a machine shop, cold start, new awardee, the thinking through of what's required in the technical data package, what is required in partnering with the right tooling builder along with the metal caster is really important, because this DLA legacy casting is atypical in terms of the requirements, the lead time and cost constraints that you need to work with. So even though it may be a similar shape to what you produce as a machined part or as a cast part, machine to final net shape, the important thing is to recognize that it's unique, it's different, and you need to plan for it differently. So B is the correct answer for this poll.
All right, thanks, Mike. So it does look like we have a couple questions in the Q&A. This one, I think I'll direct to Gary first, and then the rest of you guys can jump in as you see fit. So how does AM 3D metal printing enter into the consideration?
I had to get myself turned off. Am I on now?
Yep, I can hear you perfectly, Gary.
So with 3D printing, there's some advantages of that from both the sand and the investment process. You can 3D print the sand that was mentioned, so you could print the molds and the cores. The pattern design still has to be done the same manner as if you were going to build hard tooling. Things still have to go together the same for the cores and the molds. And then also in investment, you can print a wax or polymer pattern, which is the exact part shape, put that onto your tree, which is your plumbing system, how the metal gets in, and then go ahead and process that through the dipping process of the ceramic and treat it pretty much the same way you would a investment cast wax, except for usually you have to do a burnout rather than an autoclave because of the residual ash that's left into the shell mold. But other than that, you process it the same as you would as if it was the investment cast wax. So the other casting processes like die cast and permanent mold don't really lend themselves to using an additive process, but sand and investment rubber plaster definitely do.
All right, thanks, Gary. Mike, did you want to add anything?
No, I just think that the additive manufacturing processes are probably most capable in the metal casting arena, as Gary talked about, whether it be in this series, the air set mold cavity making process or the investment casting process. The additive manufacturing technologies are probably the most cost effective and have the greatest impact on complex parts like these DLA legacy castings than any other application of additive manufacturing. And that includes, printing directly the metal, because there's issues with the properties when you're printing in the Z direction with respect to the X, Y. Those problems don't exist when you're making a casting from these technologies. So Gary is way up the curve on this, does it all the time. And, I really admire what he does, and it's powerful.
All right. So another question from the Q&A. Well, let me actually, Thomas, who asked the previous question, had a follow-up. The question really related not to the tooling list approach, which could be substituted without any variance requests. The question dealt more with directly printing a metal part.
Yeah, and Tom, what I was saying there in my comments about metal printing, direct metal printing of a part, addresses that what you just said. I think the main thing is the properties are not established of direct metal printing at this point in time. But regardless, even as that technology improves, all of the geometry that you can bring to bear with using additive manufacturing to create a mold, and then do that much more quickly, as well as have all the properties that you can achieve, not only from the solidification integrity of a casting, but also the stress resisting geometry that you can apply to a casting, is really, in my mind, the most powerful use, and will be, compared to direct metal printing long term.
All right, perfect. It looks like Tom said thanks, so I think we answered the question on that one. So another question, Mike, I'll keep you talking for a minute. In fully machined aluminum components versus machined aluminum castings, even if there's the same alloy, why is there sometimes an issue with stress corrosion cracking in the machined version?
That has to do with the grain structure, Julia, of wrought metals versus cast metals. And the short answer is that cast metals are isotropic in their grain structure, which means that they have rounded grains and they don't have any orientation. But in machined parts, you're starting out with a wrought block that's either been rolled or forged. And so therefore the grain structure is flattened in the direction that you forge it or you roll it. Well, then those the grain structure is all aligned. If you begin having stress corrosion in those grains, which you can have in either case, cast or machined from wrought. Well, in the case of the machined from wrought stock, those grains are already aligned in lines along the longitudinal axis. So it's easier for a stress corroded grain boundary to leap to the next boundary and start forming crack propagation. In the case of a casting, because their grains are rounded and they're not aligned, it's much more difficult for a crack to propagate. So, that's the short answer as to why in the same alloy and in the same heat treat, a casting is usually, and this happens in Keith's experience a lot, where you'll see a cast version of the same component not have a stress corrosion cracking failure.
And then a follow-up to this question, would machining an aluminum product out of a cast billet or preform solve the stress crack issues with wrought materials?
Well, if the cast billet did not have any rolling or forming previous to that, then yes, you would still have that nice rounded unaligned grain structure that you're machining into. So yes, I would agree with that.
Michael, I'll follow up to that, as you can adjust some of that with the heat treat, because some of your alloys, aluminum alloys that contain copper, like a 7075 or a 206, tend to have that stress corrosion problem, and you can address it from a T6 to a T71 heat treat and help that. You may not solve it, but you can help it. And that issue is across wrought or cast materials.
That's right, Gary. In fact, if someone wants to look into that further, back up in the recording of the webinar where Keith shows a table of various alloys and their heat treatments, and you can see that very thing, that the heat treatment difference on the same alloy can make a significant difference as to the phenomenon of stress corrosion cracking occurring or not.
All right, thanks, Mike and Gary. So somewhat related in that it's still in the machining from billet vein. For directly machining from billet, do you need to create the CAD info and 3D geometry for cutter paths? Can this be done from the tech package supplied for a casting?
Yes, you have to still generate the 3D model from the 2D drawing.
And that's an
All
important point. I don't mean to step on you, Gary, but nowadays all of the the tooling paths and so on are created from digital technology. Certainly the tooling nowadays is built from a prior built solid model, but those solid models or those tool path geometries are not the approved source for inspection. So on these DLA legacy parts, it's always the 2D drawing, regardless of the fact that today's technology has moved on and moved on further rapidly. When you're looking to get a first article approved, your technology that you use to create the solid models, to create the tool paths and so on is not the answer as to whether the part's approvable or not. It's the 2D drawing.
You can build it the new way, you inspect it the old way.
Right.
All right, so I think Gary may have just addressed the next question, which is when substituting a machine from billet of forged preform, do you still need to follow the inspection requirements that are in place for the casting, perhaps X-ray, dye penetrant, etc.?
Well, X-ray is going to be an issue because yes, you can X-ray it for the quality level, but it's going to be different on billet than it's going to be on a piece of wrought on a casting. There's different call outs that would be used, but they probably could be cross-interpreted. But I've had that issue before. People say, well, just cast me a billet and X-ray it and I'll use it and hog the part out of it. Well, that just doesn't really work real well from the standpoint of meeting all the requirements. So I guess the answer is yes, it could be done. It could get tricky.
All right, so I have one more poll question for you guys. So I'm launching it now. It's on residual stress. So it's, are residual stresses formed in the machining and casting processes? And it's multiple choice in the sense that you can pick multiple answers. So that's a hint that there's probably going to be more than one correct. So we'll give everyone another minute or so just to read through the answers. All right, so I'm going to go ahead and end the poll, and I'll ask Mike to talk about the answers. So Mike, it looks like most people had the correct answer in yes in the machining process as well as yes in the casting process, but there may have been just a little bit of confusion with one of the answers being not in the machining process because existing prior stresses in the rolled or forged blanks are relieved by the machining cuts. So if you could explain why that is not the correct answer, I think that would be great.
Yes, the relieving of prior stresses in the wrought metal, those tend to be stresses that are more uniform across the entire block or forged bar, whereas the residual stresses that are created by machining cuts get to be larger when you get into corners and local areas. So the relieving of stress does go on by machining the residual stresses from the rolling or forged forming, but those tend to be overall and more general and lower, and the ones that from machining either heavy cuts or machining into corners and geometry that's more complex tend to be larger and local.
All right, perfect. Thanks, Mike. So one question that I'm curious about, if we're fully machining and not casting, what is the most significant risk reducing benefit to doing that? And then on the flip side of that, what kind of risk concerns are there with fully machining versus casting? So pros and cons, if you will.
Well, I'll jump in, and I'm sure Gary and Keith might have comments about this too. But from a risk reducing benefit, just the accuracy of the machining process, particularly with all of the multi-axis capability of not only the spindle, but the pallets. It's amazing the accuracy that you can achieve with really complex geometry. So just being able to blast past what the typical cast features are capable of is a great benefit of being able to machine complete. Now, the machine surfaces themselves, either way, would be the same, but so many, most machined castings, this is an amazing fact, but even simple castings are typically more than 80% as cast surfaces, and they get more and more complex. You get up over 90-95% as cast features. You don't machine very much. So it is an advantage to be accurate on all of those 80-90-95% of what would have been as cast features. But on the other hand, and Keith did a great job of explaining this, the unfamiliarity of the straightening process on complex geometries in any of the precipitation hardening alloys, which would be the aluminums and magnesiums foremost, but some of the high alloy cast steels are precipitating hardening too. So what happens is, if you don't have not only the fixtures to check and to straighten to, as well as the heat treating close by, because as Keith said, you're only talking about hours before the casting becomes too stiff due to the age hardening process, then you can't straighten it at all. You have to go back to heat treat. So if your heat treater is 60 miles away, this is going to be a train wreck. And so your consequence is going to be dimensional failures where you just couldn't get it straightened to print.
Yeah, I'll jump in and add one thing there, Mike. I think we all probably would agree that we're going to be using these legacy weapon systems for a long time in the future. So even though the current contract award is for a small quantity, I think we could probably think realistically in terms of repeat follow-on buys for a long time. So I think economically, it might be better to think in terms of, hey, if I do this as a casting, I can probably in the future make more profit as these follow-on buys come along, because I will have already developed new tooling if I couldn't find tooling, and developed a casting partner that I'm working with, and the the amount of material removed from the casting is less. So I would think in terms of, hey, what's the future going to look like for these things? I'm probably going to be able to have follow-on awards, and I'm going to be more competitive the next time I bid if I produce these things with a casting, do take the necessary steps of finding tooling, existing tooling, or building new tooling, and lining up my casting partner, getting all these steps established. I'm going to be more competitive the next time around if I do a casting.
Well, that's a good thought, Keith.
All right, so last question that I see. So is machining the castings different than machining other shapes that are made from, let's say, forged blanks or bars?
Well, you're still
Greg.
starting.
Yeah, go ahead.
You're still starting with a preformed shape. So the biggest issue is setting up to the proper points. Hopefully you've got tooling points that are followed through from the casting or forging process right on through the machining. You set up on those points, the foundry is inspected from those points to ensure that all the cast features are going to come into the proper location. Many times you get a machine shop that just kind of sticks it in there, randomly starts it, and then they find out, well, I ran out of stock on the other end of the part or something. So the setup becomes much more difficult and needs to be followed carefully in order to use, if you're using a casting or a forging, to ensure you maintain those already cast features.
Well, that is right on, Gary. And in fact is, I produced castings for 25 years, and I had 2 machine shops that were really good at castings. And they were the only ones that I used because they understood just what Gary said about setting up. Because when you're machining casting, you're going to have to set up somewhere, and that somewhere is an as cast feature. So what I found was that if I worked with random machine shops, they would mismachine good castings so often that it was just impossible to have a good relationship with them. They'd always be arguing with me about why I gave them a bad casting when in fact they didn't know how to set up. So I only did business with 2 machine shops who knew what they were doing with castings and specialized in those. We also see metal casters who will invest in their own machine shops and machine them themselves just to avoid the difficulty of having mismachined castings and all the arguments about who's responsible for what. So if you are a machine shop bidding on castings and you're really unfamiliar with them, we did a series last year, and Julia can give you a link if you email her to the 2 segments of the second webinar we did, which emphasized the differences between machining from wrought stock and machining casting. That would be a good way, to help yourself get launched in a whole new way of machining to net shape from a casting.
All right, so Mike and everyone on the line, just as an FYI, I put the link to our YouTube channel. So this has all of our previous webinars. So if you're interested in learning more, check those out. I don't see any more questions. So real quick, I am going to put in my email in the chat as well. I know several people were interested in attending this for the continuing education credit. So if you need a certificate for attendance, please send me an email. And as well as if you have any questions or anything that you think the CASET team can help you with, we are funded by DLA, so we thank them a lot for that. But we are a resource, and we're here to help you guys. So really, I just want to thank everyone for participating. You guys had great questions, and we love getting the chance to answer them. We are going to have part 2 of this webinar on September 21st at 11 Eastern. So I am going to send out the registration info for that as we get closer, and I'll send out as well the recording of this webinar to all of you guys. In addition, I would greatly appreciate if you would fill out our really quick survey. I think it's 3 or 4 questions, mostly multiple choice. We really do value your feedback, and I mentioned at the beginning that we've changed our format a little, and we've done that based on the feedback we've received in the past. So yeah, we want to make sure we're getting you guys the information you need moving forward. But I think that is all I have. So again, if you have any questions about content or need any assistance with anything regarding castings, please reach out to me. But other than that, I hope you guys have a great day.
Thanks, Julia. Good job.
All right. Thanks, Gary. All right. So I'm going to stay on for a minute or so, just so anyone who needs my email or any of the links I put in the chat can grab those and copy and paste those, but feel free to drop off if you don't need those.